A logarithmic function is defined as y equals log base a of x if and only if x equals a to the y. It is used to evaluate the value of an exponent. Y would be equal to the exponent, a is equal to the base, and x would be the value. If and only if x is equal to a to the y power. For example, log base 2 of 32 equals 5. In exponential form, it is written as 2 to the 5th power equals 32.
Now I will be teaching you how to find the logarithmic function on a calculator. This specific technique can only be done when the log has a base of 10. This is called a common logarithmic function. So say I have the function f of x equals log base 10 of x, where x is equal to 10. You would input this in the calculator by first pressing the function log. Then, since x is 10, you would then input the number 10 and press enter. Your calculator then will display the answer, and here we get 1. Note that if your calculator displays error, for example, if I input log -2, it shows error. This means there is no real power to which 10 can be raised to obtain x, in this case, -2. Now let's take a look at the properties of logs. The first one is log base a to 1 is equal to 0. This is because a to the power of 0 is equal to 1. Hence, the logarithm of 1 to any base is 0. Now, let's look at the property 2. Log base a to a is equal to 0. This is because a to the power of 1 is a. For example, log to base 10 to the power of 10 is equal to 1. This is because in the exponential equation, we know that 10 to the power of 1 is equal to 10. Property 3 is log base a of a to the power of x equals x, and a to the power of log base a of x is equal to x. This is an inverse property. For example, if you simplify log base 5 of 5 to the power of x, this is equal to x. Property 4 is if log base a of x is equal to log base a of y, then x is equal to y. This is known as a one-to-one property. For example, if you were to solve for x for log base 2 of x equals log base 2 of 3, x would equal 3.
Logarithmic functions can be graphed. The parent graph of a logarithmic function is the inverse of the exponential function and is reflected over the line of y equals x. To graph logs, it's easier to make a chart like the one here. It is important to use the common logarithmic function if no specific function is given. Right here we are using random numbers 1, 5, 8, and 10 with the logarithmic function f of x equals log base 10 of x. You can use either a calculator or common mathematics to solve for each value and then graph like here. For another example, we will be using f of x with log base 2 of x. We are using random numbers 4, 8, and 16, and the values are 2, 3, and 4. Draw your graph, x and y axis, and then graph according to your chart. Here we are going to describe transitions of log graphs. Let's say you have the natural log of x, and here's the graph. Let's say you have natural log of x minus 2. This would mean we move it to the right 2 points. The x-intercept of y equals natural log of x minus 2 is 3, 0. And the vertical asymptote is located at x equals 2.
Hello, I'll be talking to you about the natural logarithmic functions. The natural logarithmic function is the inverse function of a natural exponential function. It is written with the special symbol of x. It is read as the natural log of x, or ln of x. The functions of a natural log is for x is greater than 0. Other functions would be y equals ln of x only if x equals e to the power of y. The function would be fx equals log base e of x, which is the same as ln of x. And x can be written without a base. It can also be read as ln base e of x, which is the same as log base e of x. Now you will try to evaluate the natural logarithmic function on a calculator. So you would use a calculator that has ln. You would click ln and you would also insert the number and enter to find the answer, which is usually a decimal number. So, for example, this will be how it'll look like on a calculator. So it'll be, you type in, like you click the ln button and then you write 2 or a number, example 2, and you would enter. Now you will be using the properties of natural logarithms. It is the same as the other logarithm properties, but it will be used as a special case for a specific base of e. So the first property is ln of 1, which is equals to 0 because e to the power of 0 is equal to 1. Number 2 is ln of e is equal to 1 because e to the power of 1 is equal to e. Number 3, ln of e to the power of x is equal or the same as e, which is equal to x, which is the same as e to the power of ln of x is equal to x. And number 4 is if ln of x equals ln of y, then x will equal to y. Now you'll be using examples from the properties of natural logarithms. Letter A will be ln of 1 over e. It would also be ln of e to the power of negative 1, which also equals negative 1. B would be e to the power of ln of 5, which also equals 5. Letter C, 4 ln of 1 is 4 times 0, which equals 0. Letter D is 2 ln of e is equal to 2 times 1 equals 2. Now you will be finding the domain and range of the function. The range would always be all real numbers. And finding the domain is not all real numbers. I will be giving you one example which will help find the domain. So the example is fx equals ln of x minus 2. The range, of course, will be all real numbers. And the domain will be 2 to infinity because it is defined by x minus 2, which is greater than 0. It will go right to infinity.